Hey, welcome to the Explainer. Have you ever thought about this? Could the entire mind-boggling universe of particles actually be built from just two simple ingredients? Well, today, we're diving into a theory that says, yes, it can. And it does it by using a set of elegant blueprints to basically construct reality itself.
It sounds a little nuts, right? I mean, how do you get all this complexity from something so simple? That's the big question. And the Rishon model has a really fascinating answer. It turns out it's not about the ingredients. It's all about the blueprints.
Okay, first things first. Let's meet our two ultimate building blocks. We've got T for time-like and V for velocity-like. Seriously, that's it. Think of them as our only two types of Lego bricks. Now, here's the crucial part. They have an opposite property called color value. Just imagine one is a plus brick and the other is a minus brick. As you're going to see, any stable thing we build has to have its pluses and minuses perfectly balanced out.
But we don't actually build with the raw T and V bricks. Instead, we use their specific manifestations, which are called expression images, or EIs for short. You can think of these as the prefabricated parts, all ready for assembly. And how these EIs get arranged? Well, that's what decides everything.
So, what's in the instruction manual? Before we start building, let's just quickly go over the ground rules for how this all gets put together.
Right. These assembly rules are absolutely key. First, remember our plus and minus bricks? Well, any particle we build has to be neutral in the end. The color charges have to balance out to zero. That's rule number one. Second, each little piece has this thing called a Rishon number. And finally, these properties can change through quantum entanglement. Don't worry too much about the deep physics there. Just remember, balancing the charge is the most important rule for all of our blueprints.
Okay, let's jump into our very first blueprint. This one is for what we call generic Rishons, and they follow a really distinct recipe.
So the blueprint for a generic Rishon for a very specific mix. You take a pair of our regular building blocks, the images, and you combine them with a single anti-image, which is basically its matter-antimatter opposite. Or you can just flip the recipe. Two anti-images with one regular image. The key thing here is that it's always a mix.
So in this mixed-up group, how do we figure out the color? Well, it follows something called the odd member rule. It's super simple. In this group of three, the two that are alike kind of cancel each other out. That leaves the single lone member, the odd one out, to define the entire group's color. Simple as that.
So the main thing to remember for this blueprint is teamwork. In a generic Rishon, every single component is active. Each one has color, each one has a Rishon number of 1/3. They all contribute equally to the whole structure. Now keep that idea of equal contribution locked in your head because it is about to change. Completely.
All right, next up is blueprint number 2, the prime Rishons. And with this one, a totally different set of instructions is going to lead to a fundamentally different kind of particle.
See the difference right away? No more mixing. For prime Rishons, the blueprint demands groups made of only images or only anti-images. We are no longer combining them. And this one little change in the recipe, it has huge consequences for what we end up with.
The color rule also does a complete flip. Instead of the odd one out in a mixed group, we now have the unpaired rule. So in this trio of images, two of them form a neutral pair. That leaves the single unpaired image to be the sole decider of the group's color.
And this creates a really clear division of labor. You know, unlike the all-for-one teamwork we saw with generic Rishons, here, the two paired images are basically neutralized. They have no color charge, a Rishon number of 0. They're just kind of there. All the responsibility, everything that defines the particle, falls on that one single unpaired image. It's the only one doing the work.
Okay, on to our third and final blueprint. This one builds what are known as flavored Rishons. And as we're about to see, it gets there by taking the last rule and turning it completely on its head.
Now at first glance, the recipe looks exactly the same as the prime Rishon blueprint. It's still made of image-only or anti-image-only groups.
I mean, they start from the exact same setup, and that's what makes the difference in the next rule so incredible.
And here it is, the twist. For flavored Rishons, the color is decided by the paired rule. This is the total opposite of prime Rishons. That single, unpaired member, we now ignore it for color. Instead, it's the two paired images that work together, combining their complementing colors to set the final color for the whole shebang. Just look at how everything has been inverted. Now, it's the paired images that are the active ones. They're the ones carrying the color charge and the Rishon number. They define what the element is. And that unpaired image that used to be so important, now it has no color. Its job has totally changed. The roles have completely flipped.
Okay, we've walked through 3 different blueprints. Now let's put them all side by side because this is where it all clicks. This is that aha moment.
This table says it all. Just look at the beautiful pattern here. Generic Rishons, they're defined by their mixed recipe. Prime and flavored, they're defined by their unmixed images-only recipe. But the real story, the amazing part, is in that color source column. For generic, it's the odd one out. For prime, it's the single one. For flavored, it's the collaborating pair. Each blueprint just assigns the job of deciding the color to a different part of the structure.
So, here's the bottom line, the most important takeaway. We are using the exact same fundamental pieces, those expression images of T and V, in all 3 cases. The only thing that changes is the blueprint, the set of rules for how they're arranged, and how we determine color. This is how simplicity creates complexity. It's not about the parts, it's about the pattern.
So we've got the rules down, but what does all of this actually, look like? Let's check out the visual language for it.
The visual code is actually incredibly simple. Any V-type images are shown as little cones in the top half of a circle. Any T-type images are cones in the bottom half. And whether the cone is on the left or the right helps decide its color charge. Easy enough, right? Let's see it in action.
And here it is. This is the result of all of those rules we just talked about. This is the complete graphical library of all 48 possible Rishon expressions. Every blueprint, every rule, it all comes together to create this visual periodic table of particles.
Let's just break it down real quick. Take a look at the first and third rows. Those are our generic Rishons. See that visual signature, that mix of the matter and antimatter components? That's the hallmark of Blueprint 1, the one that required mixing images and anti-images. Now look at the second and fourth rows. These are our prime and flavored Rishons. And you can literally see the rules we just learned. You can spot the white pairs in the prime Rishons. Those are the neutralized parts with no color. And you can see the colored pairs in the flavored Rishons, the ones that combine their colors. It's all right there, encoded in the visual language. So we end up right back where we started. We've seen how just 2 fundamental ideas, T and V, can be put together according to 3 simple blueprints to create an entire family of particles. It all just comes down to the pattern. Which leaves us with one last thought to chew on. If the identity of a fundamental particle isn't about what it is, but simply about how its pieces are arranged, what does that tell us about the nature of reality itself?